Hey everyone, in this session we will be discussing on gradient boosting. Gradient boosting is an ensemble learning algorithm used to solve both regression as well as classification problems. It is a boosting based machine learning algorithm. If you are not aware about ensemble learning techniques or boosting technique, you can watch my previous video where we have discussed about ensemble learning methods. This picture depicts the boosting technique. In boosting technique, we create a strong learner with the help of a number of weak learners added in sequence. Let's understand why gradient boosting algorithm is very popular among machine learning engineers and data scientists. There are a number of advantages of gradient boosting, why it is so popular in the community. It has a very high predictive accuracy. It can handle heterogeneous data. That means even if you have few columns of categorical data and few columns of continuous data in your training data set, gradient boosting can handle it well. So no need to perform intensive feature engineering in case of gradient boosting. We can even evaluate the feature importance for a specific problem statement with this model. If you have a number of features in your training data set, with the help of gradient boosting algorithm, we can identify the most important features from the dataset. During our coding session, we will see it in action. However, we must know the disadvantages of gradient boost algorithm so that we can use it effectively. Gradient boosting algorithm is computationally expensive. It is very sensitive to hyperparameters. It is prone to overfitting if hyperparameters are not correctly tuned. Hence, while using gradient boost algorithm, we have to put considerable amount of effort to perform the hyperparameter tuning. Now, as we have realized why gradient boosting is a very famous algorithm among the community, let's understand how can we implement it in our Python code. Using sklearn library, we can import gradient boosting regressor. Remember, gradient boosting helps us to solve both regression as well as classification problem. So sklearn.ensemble has both gradient boosting regressor as well as gradient boosting classifier. During our coding session, we will try to solve a regression problem. Hence, we have imported gradient boosting regressor here. However, if you want to solve any classification problem, you have to import gradient boosting classifier. Once you have imported it from sklearn library, we will be able to create a gradient boosting regression model with the help of constructor. Gradient boosting regressor takes a number of hyperparameters. The most important hyperparameters are n estimator, max depth and learning rate. Using n estimator, we will be able to limit the number of weak learners we will be using for our prediction. Remember, gradient boosting is prone for overfitting. Hence, with the help of max depth, we can limit the depth of the decision tree to be used as weak learner. By default, gradient boosting algorithm uses decision tree as its weak learners. However, we can always change the type of weak learners we want. Learning rate specifies the influence of each weak learner towards the final prediction. By default, learning rate is 1. After creating the model, we can use fit method and pass the training data in order to train the model. Once we have well-trained model, the model will be ready for prediction. To evaluate the accuracy, we will be using score method, which takes test data as its input. The score will be between 0 to 1. 1 means 100% accurate. As we have discussed in our previous slide, with the help of gradient boost, we can even identify the feature importance of a particular problem statement. We can print the feature underscore importances underscore attribute to get the feature importances. Let's jump to Jupyter Notebook and write some code to solve an example regression problem so that we can understand how easily with the help of sklearn library we can implement gradient boost algorithm. We are in our Jupyter notebook. Initially, we will be importing all the important libraries to solve our problem statement. Pandas is a library which will be used for data preparation. We will be importing gradient boosting regressor from sklearn.ensemble. Train test split method used to split the entire dataset into training dataset and test dataset. We will be using this method in our data preparation process. Hence, we are importing it in advance. Matplotlib used to visualize the data. We will be using few visualizations in our example. Hence, I have imported Matplotlib. I have downloaded Google stock price for the year 2023. Let's see how the data looks like. Our data has a number of columns. We have date, opening price, high and low, and closing price of Google share for a day. Volume is depicting the total number of shares has been transacted for that particular day. We are creating our feature data frame with open price, high, low, and volume. Our target will be to predict the closing price of a Google stock based on the open price, high, low, and volume. We are also creating a target data frame where we have the closing price for each date. Using train test split, we are splitting the entire data set into two parts. 80% of the data will be in our training data set. Remaining 20% of the data will be reserved for testing the model. Once we are done with the data preparation, it's time to create gradient boost model. We are creating gradient boosting regressor because our problem statement is a regression problem. After creating the model, we will be training the model with the help of training dataset. Once we have trained our model can provide the accuracy value if we run model.score method. Remember, we are passing test data as the parameters of score method. See the beauty of gradient boost model. Without putting considerable amount of effort, we could create a model which is of 98% accurate. However, as we have discussed during our theory session, hyperparameter tuning is a very important step for gradient boost algorithm. If we do not perform effective hyperparameter tuning, our model might be prone to overfitting. In order to perform hyperparameter tuning, we can use grid search CV from sklearn.model selection. If you are not aware about grid search CV, we have a dedicated video for it in this same playlist. You can watch the same. Using grid search CV, we can use a number of different combinations of hyperparameters for our model and identify the best parameters out of it. Notice here, we are providing three different options for each hyperparameters. Grid search CV estimates the accuracy of our model with all the combinations of these three hyperparameters. And finally, it will also identify the best parameter combination. Let's run this. It takes some time because it evaluates all the combinations, and finally we could get the best parameters for our model among the values we have provided as a part of params. So if we put learning rate 0.1, max depth 2 and n estimator value as 10, we get better accuracy for our gradient boost model. Let's understand how we can evaluate feature importance for a specific problem statement with the help of gradient boost algorithm. Once we have trained gradient boost model, we can use an attribute called feature underscore importances to get the feature importances. I am using a horizontal bar graph to depict the importance values. Among all 4 different features or the independent variables, the most important column is the opening price. Second most important column is the low value and then the high value as per our trained model. And there is no importance of volume column in our dataset. With the help of these feature importances, you can easily identify the important columns of your training dataset. If the columns are not contributing towards the prediction of the model, you can remove them safely. In our case, we can safely remove the volume column from the training dataset. Hope you have realized how we can evaluate the feature importances and what is the significance of evaluating the same. Now we know how can we implement gradient boosting algorithm with the help of sklearn library in a machine learning code. In our next slide, we will understand how gradient boosting algorithm works internally. Initially, gradient boosting starts with an initial model, often a single noded tree, which calculates the mean value for a regressor. So in our case, it will evaluate the average value of our closing price column. After that, it calculates the pseudo residuals for each sample in the training data. Pseudo residual value will be something like this: actual target data minus predicted target data for each record. Once we get the pseudo residual value for each record, we can train a new model, usually a decision tree, to predict these residuals. Remember, we are not predicting the closing price of the share, rather we are predicting the residual values we have evaluated in our previous step. This new model is also considered as a weak learner. As a part of our next step, we add the new model to the ensemble, adjusting the predictions by a small step size called learning rate. Learning rate used to prevent the overfitting. If we keep very small learning rate, for example 0.01, it will eliminate the overfitting problem of gradient boost. If you are not aware about overfitting problem of a machine learning model, you can watch my previous sessions of decision tree algorithm where we have explained the overfitting problem in details. We repeat step number 2 to step number 4 until a predefined number of models have been added in the ensemble or certain level of performance is achieved. Remember, we used n_estimator to predefine the number of models we will be using for our gradient boosting algorithm. So the total number of weak learners will be same as the value we have chosen for n estimators while creating the gradient boosting regressor for a regression problem. The final prediction or y cap will be mean value of the target column, what we have identified from step 1, plus gamma into f1x, where gamma is the learning rate we have specified while creating the model. f1x is nothing but the prediction of the pseudo residual of our first weak learner plus learning rate into the prediction of pseudo residual from second weak learner and so on. Let's summarize what we have learned in this session. Now we know what is gradient boost algorithm, what are the advantages and disadvantages of the same. We know how easily we can implement gradient boosting algorithm with the help of sklearn library. We even discussed about the internal steps involved in gradient boosting algorithm. Hope you have enjoyed this session. Thanks a lot for watching this video.